Welcome students. In today's session, we are going to learn about various methodologies used for developing a software. We are having three most popularly used methodologies and almost all the methodologies will be modeling a business problem and then it will be developing the solution or it will be designing the solution for that problem using object-oriented approach. The only difference between each methodology is the level of documentation it provides to the user and the notations and languages used by the methodology to design the software. So these two will be the differences in each methodologies, but all the methodology will be developing the solution for the problem, business problem given by the customer. So we have three most popularly used software development methodologies. One is Romberg et al. Methodology, second is Buch methodology, third is Jacobson methodology. So first let us see about Romberg et al. Methodology. Now let us see about Romberg et al.'s methodology. This methodology will be using object modeling techniques. So here you will be having objects and using that objects this methodology will be working. And this method is an fast and intuitive method. So this method is used for rapid development of the software. This method will be having three phases like analysis phase, design phase, and implementation phase of a system. So these are the three phases developed by Romberg et al. Methodology, developed when we are developing a software using Romberg et al. Methodology. And then this methodology will be having some details like classes, methods, attributes, inheritance, and associations we have in the classes. Associations we have between classes and the inheritance we class between classes. So this method, Romberg et al. Method, will provide details such as classes, methods, attributes, inheritance, and association that we have between the classes. So this method is an dynamic method. So we have dynamic object behavior. So you can change the requirement of the user at any stage of development of the system. Then in this method you can have process description as well as consumer-producer relationship. This process, Romberg et al.'s object-oriented modeling technique, OMT technique, consists of four phases. First phase is analysis phase, and the second phase is system design phase. Third phase is object design phase. And the fourth phase is implementation phase. In analysis phase, you will be collecting the requirements from the user so that you can obtain dynamic objects and functional models in the analysis phase. And next, the system design phase. In this phase, you can have the basic architecture of the system. So this phase gives the basic architecture about the system. And the next phase is object design phase. In the object design phase, you can have the design documentation design part. And then the next phase, implementation phase, you will be providing the reusable codes so that the designed part or the developed part of the software will get implemented in a working environment. So these are the four steps we have in a software development by using Romberg et al. Methodology. So we have analysis phase, system design phase, object design phase, and implementation phase. Object modeling technique designs the system by three models. One is object model, another one is dynamic model, other one is functional model. Using these three models, object modeling technique designs a system. So first let us see about object model. Object model. Object model describes the structure of objects. It says about the relationship between objects, how the objects will be communicating with each other, what are the attributes and functions the object is working on. So these informations will be provided by this technique, object model technique. And we can have an example for object model technique. In object model technique, we will be using object diagram. So by using object diagram, you will be designing the objects, and how the objects will be communicating with each other will be described. So let us see an example for object diagram. This is the object diagram for a banking system. Here the boxes represents classes. So this is a client class, this is an account class, this is a transaction class, this is checking account class, and this is a savings account class. So this boxes represents classes. And here in the client class, you will be having the attributes like first name, last name, pin code. So let us go to the account class. In the account class, you will be having the attributes like number and balance, account number and the balance in the account. And you will be having the functions like depositing to the account, withdrawing from the account, creating the transaction. So these are the functions we have in the account class. Next, we will be moving on to transaction class. So in the transaction class, you will be having attributes like transaction date, transaction time, transaction type, amount, and post balance. So these are the details, or these are the attributes we have in the transaction class. In checking account class, we will be having only one attribute called withdrawing detail. So this is only one attribute we have in checking account. The next is savings account. So this is the class. So in savings account class, you will be using this class for communication. And next is this triangle symbol represents the specialization of the classes. That is, here account is the superclass. This account class is the superclass. From this superclass, you are having, you have inherited two subclasses, two child classes. One is saving account class, another one is checking account class. So this triangle symbol implies the specialization part. That is, checking account class and saving account class are the child class of the superclass account class. So the next thing is this line. These lines represents the communication. These lines are called as association lines. This lines represents the communication between one class and another class. Here, this first line, client account association line, represents the communication between the client class and the account class. And here, the account transaction association line represents the communication of objects of the account class with the objects of transaction class. Similarly, you have another association line called checking savings account. So in checking savings account association line, this line represents the communication of objects from checking account class to the savings accounts class. So these are the association lines, and these lines says the communication of objects of one class to the objects of other class. The next thing is, here this round represents the cardinality of association. That is, one account, that is one customer can make more than one transaction. So this round symbol implies many transactions that are done by a single customer is represented by this round symbol, circle symbol. So this association line says for a single account, for a single customer account, you can have more than one transaction. That is, one to many transaction will take place here. Whereas in the client account association line, you are not having any circle here. That is, one client may have only one account. In our example, we are not considering about joint accounts. We are only considering single account. So here the client class and account class objects will have only a single to single relationship between each other. So this diagram says about this is an object diagram, and this object diagram says about the classes in our system and how one object will be communicating to other object in the system. The next model used in Romberg et al. Methodology is dynamic model. In dynamic model, you will be having state transaction diagram. The state transaction diagrams will have states in your system and how the transactions are taking place between these states, how the system is moving from one state to another state by a transaction. So usually a state will be taking one event as input, and based on the event, this one state will be moved to other state. So this movement of one state to other state is called as a transaction. This is the state transaction diagram. Here this dot implies the starting phase, and the circles implies the boxes, circle boxes implies the states of the system. Here nothing is selected as a state of my system and account has been selected as another state of my system. Similarly, you have some states like enter the amount, confirmation. So these boxes represent states in my system, and this arrow marks implies the transaction that takes place between the system. For example, if an event like no account has been selected, if this is the event, there may be no transaction, so the state will not be changed. The state will remain as nothing is selected state. Whereas if an account is selected, my event is selecting an account, in the sense if my event is taking place, then nothing is selected state will be moved to account has been selected state. So the movement of one state to another state will be represented by this arrow symbol. This is a transaction phase. So this indicates the transaction from one state to another state. After the account has been selected, if you are selecting the checking account, then the state will be moved to checking account state. Then you will be moving on to saving account state. So once you have entered into saving account state, if you are making an event like withdrawal, deposit and transfer, you will be moving to other state like selecting the transaction type like withdrawal, deposit and transfer. So when you are selecting an event like withdraw, if you are going to perform that event, then the next state will be enter the amount state. So my transaction will take place here. After entering the amount, you will be asked about the confirmation. So here one transaction is taking place. My state is moving from entering the amount state to confirmation state. So these boxes represents the states and this arrow marks represents the transaction between one state to another state. So this is one state transaction diagram of banking application. The next phase or the next model used in Romberg et al. Methodology is functional model. Functional model will be having data flow diagram. That is, this diagram says how the data is moved from, or the flow of data from one state to another state, from one process to another process. Let us see the data flow diagram with a neat example. Let us see the flow of data in a banking application. Here, ATM card reader is an external entity. So you will be entering or you will be inserting your ATM card in this card reader. So after your ATM card has been inserted, the next process will be selecting the bank. Either you will be selecting the bank. So the bank information will be taken from the Circastium. So here, after selecting the bank, you will be asked about the card details. First step may either be selecting the bank, or some ATM card reader may directly ask about your card details. So if you are going for bank selection, first you have to select the type of bank and then you have to select the type of card. So when you are selecting the card, type of card, the card detail and bank detail will come from the previous processes and external entity. So after selecting the card, then you have to verify yourself. That means you have to authorize yourself. You will be giving your PIN number. So this PIN number will be entered using the keyboard what you will be having in your ATM card. So after entering the keyboard, the password data will be transferred from this external entity to the verify password process. And here in this verify process password, the password will be checked with the PIN number what you have got from your database. And once the password has been verified, then you will be asked about your account type, whether you are having a savings account or current account. The type of account what you have has to be selected. For this, account type will be entered by the user in the keyboard what you have in the ATM card reader. So from that keyboard, account type will be, the data account type will be entered into the select account process. So in the select account process, you will be selecting the type of account in your banking, and then the account details will be collected from the data account. So this is the data store. In this data store, you will be having the details like savings account, which accounts are savings accounts, which accounts are current accounts. So the details will be collected from the account data store. And then the next phase is either you can withdraw, deposit or check your balance. You can update your account details. So for that, user will be selecting some options like withdrawing deposit, like options like that in the screen, ATM screen. So in the external entry he will be selecting the option. So that option, amount or transaction type, will be the data will be sent to the update account process. In this process, either withdraw process or deposit process or balance checking process will take place. So for checking the balance, you will be using the data store account. So in this account data store, you will be having the balance details of a particular customer. So you can use that balance details. And then after completing this update account process, you will be generating the receipt, and the receipt will be given to the user in an external entity using the ATM card reader machine. You will be giving the receipt to the user. So here ATM card reader, keyboard entry, screen selection, and receipt to the user, all these things are external entries, external entities you have in a real world. And from the external entity you will be collecting your data, and based on the data what you have collected from the external entity, the processes will work. So these processes also will be transmitting some data between each other. For example, in this case, if you are selecting a bank, in the first process, if you are selecting a bank and if that bank is not available, then you will be having an termination called bad bank code. If you are selecting a card and if that card code is not there, then your system will get terminated or your transaction will get terminated. And if you are typing a bad password, again your transaction will get terminated. If you are typing a bad account, then your transaction will get terminated. And also if your transaction fails, like if you are updating the account, all the transactions should be completely done. Whether in middle of any account updation, if any power loss or any other miscellaneous happens, and if this account transaction is not completed, then that transaction has also been failed. So this is an data flow model or data flow diagram of a banking application. The next popularly used methodology is Booch methodology. Here this methodology will be having two phases like analysis phase and design phase. So this method will be analyzing the requirements from the user, and it will be developing or designing the system based on the requirements what we have collected from the user. So for analysis and designing phase, for both these phases, it will be using the object-oriented approach. And in Booch methodology, you will be having some 6 diagrams, that is class diagram, another one is object diagram, next is state transaction diagram, another one is module diagram, next is process diagram, another one is interaction diagram. So these are the 6 diagrams which are used by Booch methodology when we are developing a software. This methodology has macro development process as well as micro development process. First, let us see about macro development process. Macro development process, in the sense, this process will be controlling the framework of microprocess. So this process, as it is controlling the microprocesses, it will be taking place for about weeks and months. So designing of this macro development process will be like weeks and months. So this macro development process will be having some steps like conceptualization and analysis and development of model. Next one is design or create the system architecture, evolution or implement. The next thing is maintenance. So these are some 5 phases you have in macro development process. So in the conceptualization phase, you will be able to establish some set of goals and develop some prototype based on the requirements what we have collected from the user. This is what done in conceptualization phase. In analysis and development of model phase, you will be using the class diagrams so that you can be able to know about the objects, the attributes and the functions what you have in these classes. What are all the classes will be there in software what we are going to develop. So analysis and development of model phase will be giving about classes what we have in our software. And the next phase is design and create the system architecture phase. So in this phase you will be using the module diagram. So the module diagram will say about the transaction between each module, as well as you will be using the process diagrams. In this phase you will be designing the detailed architecture, like how one process is communicating with another process, how the transaction between the modules are taking place. All these things are dealt with the design and create the system architecture phase. Next is the evaluation and implement phase. In the evaluation and implement phase, we are refining the system. We will be successively refining the system by collecting the feedback from the users. By collecting the feedback from the user, you will be successfully refining the system iteratively. The next step is maintenance. In the maintenance steps, you will be making some localized changes, and then you will be eliminating some bugs in the system. So these are the two steps what we do in maintenance. So macro development process will be having these 5 analysis phases. First is conceptualization, next is analysis phase, next is design phase, and the next is implementation phase, and the next is maintenance phase. Next is micro development process. Micro development process, each and every macro development process will have its own micro development process. This can take place by day-to-day activities. This can be completed in day-to-day. So this is called as a micro development process. And this micro development process will have steps like, first thing is we have to identify the classes and objects. The next thing is you have to identify the classes as well as the objects relationship or object semantics. So next we will be collecting the object semantics, and then you will be collecting the classes and objects relationships. The fourth step, you will be identifying the classes and objects, interfaces and implementation. So these are the 4 steps you have in micro development process. This diagram says about the object modeling by Booch methodology. Here Mustang, Taurus, Escort, Ford and this car are the classes. Here car is a class and the color, manufacturer, cost are the attributes of the car class. And Ford is also a class, Mustang is also a class, Taurus is also a class, Escort is also a class. So this diagram says how one class is inherited to other class. Here car is the super class and this Ford is inherited from the car class. So similarly Ford is the super class, Mustang, Taurus and Escort are inherited the Ford class. So inherited in the sense it will be inheriting the variables, attributes and functions of Ford class. Mustang, Taurus and Escort will be using the attributes and functions of Ford class. So that is why these are called as child class. So these child classes will be inheriting the parent class Ford class. And this Ford class again it is also a subclass that will be inheriting the parent class car. This car class will be having the attributes like color, manufacturer, car, and these attributes will be used by the Ford subclass. So this diagram says about the inheritance what we can have in a car system, car manufacturing system. This diagram says about the state transaction diagram of an alarm system. So this is one example of state transaction diagram using Booch methodology. Here this is an alarm system. Here silenced, sounding, disabled. The round circles are processes, and these are the transaction that takes place between processes. This is the starting phase. Here initially our system will be in silent state. If the silent state is made to make an alarm, then it will be moving on to sounding state. If you are turning off the alarm, it will be moving on to silent state. So the transaction will be taking place from silent state to sounding state based on the alarm, based on the requirement of the user. If the user wants to make the alarm to sound, the state will be moved from silent state to sounding state. if the user is making the alarm to go to silent mode, then you will be moving on to sounding phase to silenced phase. Then if the alarm is going to get enabled, if you are going to use the alarm, then the whole system will be moved from disabled state to working state. So that is why this is called as enable state. And if you have completed your alarm work, if you are going to turn off your alarm, then your whole system will be moved from this working state to disabled state. So this enable and disable are the datas, and these are the transactions that are taking place in an alarm system. So this is a state transaction diagram for representing the alarm system, for representing the transactions between an alarm system. The next methodology is Jacobson methodology. Jacobson methodology will be having some methodologies like object-oriented business engineering, that is object-oriented business engineering, and object-oriented software engineering. So these are the two methodologies used by Jacobson technique. Let us see about object-oriented software engineering technique. So this OOSC technique will be having the objects, that is objectary, and the main aim of this OOSC is to fit the development of large and real-time systems. That is, the model what we are going to develop using the Jacobson methodology should fit to real-time working environment. So that is the main aim of this object-oriented software engineering technique. So it has to fit to the real-time environment. Here, this objectary method has several models. One is use case model, another one is domain object model, third is analysis object model, fourth is implementation model, and the fifth is test model. So these are the models that are built using object-oriented software engineering technique. So using these models, the object-oriented software engineering technique will develop a solution for a software problem, will develop a system for the user required problem. Jacobson methodology will be using widely use case model. What is a use case model in the sense? Use case model will be describing the communication between a user and a system. That is, here let us take an example of library system. Here this is one use case diagram for a library system. The member, the user of library is called as a member here, and the librarian who is supplying the books is called as a supplier here. Here member and supplier are the actors. So here this diagram represents how these actors will be communicating with the library system software. So your software will be having some process like checking out the books, getting an interlibrary loan, doing some research in the library, reading books and newspapers in the library, purchasing supplies from the outside customers. So you have to purchase the library books whenever a new edition or new version is needed by the students or readers. So this has to be done by the supplier. So supplier, who is the librarian, so he will be collecting the new articles and new books which are interested to the readers. So this is the transaction that is taking place between the librarian and the purchasing supplies process. And here the normal user of the library will be using the processes like checking out the books, getting the loan from the library, research doing in library, and reading the books in the library. These are the processes that are done by the normal user in the library. So this use case diagram says how the actors will be communicating with the software, with the system, how the actors will be communicating with the processes that you have in the system. As we have already discussed, object-oriented software engineering technique will be having some 5 stages, that is domain object model, analysis model, and so on. So this diagram represents the phases that we have in object-oriented software engineering. The models what we use to develop a software in object-oriented software engineering phase. So here the top is the use case model. By using this use case model, domain object model will be designed, and after the design of domain object model, you will be designing the analysis model, and then you will be moving on to design model, and then you will be moving on to implementation model, and then testing model. Here use case model will says about the actors what you have in your system, how the actors will be communicating to each other. So all these things will be given in the use case model. By using the use case model, you will be you will be separating the domain of each object you have in your system. After separating the domains of each object of your system, you will be collecting the requirements that needed to be collected from the user while we want the user to operate on the system. When a user want to operate on the system, he needs some inputs. So what are all the inputs needed by the software? So those inputs are analyzed here based on the object's domain knowledge, and then after analyzing the user's requirements, you will be designing the software based on the requirements what the user has given. For the designing also you will be using the use case model. For implementation, so after designing you will be implementing the designed software in a working environment. For implementing also you will be using this use case model. So after implementing it in a real-time environment, you have to test whether the implemented software or implemented system is working correct or not. For this you will be developing testing model. So this testing model will also use the use case model. So this model will say whether my software will be working correct or not. So this is an user-driven use case-driven software development approach by object-oriented software engineering technique of Jacobson methodology. Next we can see about object-oriented business engineering. This is modeling an object at enterprise level. So this object-oriented business engineering is an method or is a technique which is used to develop the objects and systems based on the enterprise level. The mark will be like the marketing standard will be like business standards. The enterprise will be using these softwares. So this object-oriented business engineering is used to develop some softwares which are used by the big enterprises. This business engineering method consists of 4 phases. One is analysis phase, another one is design phase, another one is implementation phase, and testing phase. So in analysis phase you will be collecting the requirements from the user. So in analysis phase you will be collecting the requirements from the user, and then you will be designing the system based on the requirement what the customer has given to you, and then you will be implementing the designed software in a working environment. Then you will be testing whether my software will be working fine or not. So this object-oriented business engineering technique will be developing the software based on these 4 phases for enterprise level. Thank you for today's session, students. In today's class, we have seen about some 3 major popularly used methodologies. One is Romberg et al. Methodology, other is Booch, other one is Jacobson methodology. Among these 3 methodology, Jacobson methodology is the widely used methodology because it will be having a variety of models for developing a software. You will be having use case diagram, state transaction diagram, object diagram, class diagram, domain model diagram. So all these are the diagrams or all these are the models you will be using in Jacobson methodology for developing a software. So Jacobson methodology is very efficient when compared to the Romberg methodology as well as Booch methodology. Even though all these 3 methodologies will be giving the required output or the required working for a system at the final stage, Jacobson will be an efficient one. Jacobson is the widely used one.